What's happening, dogs? Mr. Allen here with some evaluation of trig functions using our half angle formulas. So for this first one here, I've got cosine of 15 degrees. And 15 is not a nice friendly trig degree, right? It's not 30, 45, or 60 or some other one on the unit circle with that reference. But 30 divided by 2 is 15. So what if I rewrote this as cosine of 30 over 2? Is that the same thing as 15? Absolutely. So these are equivalent statements. And now what I have is with this cosine half angle formula, theta is 30. So I'll just be doing cosine of 30 within that wonderful radical that we have going on there. So it looks a little ugly, but we'll work with it. It'll be okay, I promise. I'm going to walk you through it, okay? So we got plus or minus. We'll talk about that in a moment, how you choose positive or negative for these. And we have 1 plus, well, what's the cosine of 30 degrees? Well, cosine of 30 is going to be root 3 over 2. So knowing your unit circle values or, say, your special rate triangles are going to play a key role here, okay? So I did cosine of 30, got the root 3 over 2, and I just plugged that in, okay? Now, if you're a triangle person like I am that's in the first quadrant, we got 1 for the opposite, adjacent's root 3, hypotenuse is 2, root 3 over 2. Lovely, fantastic. I love drawing triangles, okay? I'm a triangle guy. Some people are unit circle people. It's up to you. As long as you can get root 3 over 2 there for cosine of 30, you're good. All right, so now let's clean this thing up. Well, here's the deal. One thought, anyways, is I got root 3 over 2. Now, if I were to multiply this numerator, the whole thing, everything, by 2, right, that would get rid of my denominator there, and it would make this guy 2. So what I'd have here is equals plus or minus the square root of, I'd have 2 plus root 3. It'd get rid of the fraction in the numerator, right? That's awesome. But hold up. I can't just multiply that by 2. Wouldn't I also have to multiply my denominator by 2? Thus, I am multiplying by 2 over 2, which is equivalent to 1, and multiplying by 1 does not change anything. That's a legal move in mathematics. So that's a 4 down there. Lovely. And that actually works out really, really well, because the square root of 4 is 2. So now let's address the plus or minus thing here, because it's going to look wonderful here in a moment. I'm going to have the square root of 2 plus the square root of 3, all in that root, all over 2. But my denominator doesn't have a square root, so we're okay in the land of mathematics. That's an okay final answer. Everybody freaks out about radicals in the denominator. I don't think it's a big deal, but it's mathematical practice. We get rid of them. This one doesn't have it. We're good to go. So is it positive or is it negative? Well, where is 15 degrees? It's in the first quadrant. So it's wherever this angle is, that'll dictate whether it's positive or negative. So since 15 is in the first quadrant, all of our trig functions are positive in the first quadrant, including cosine, because all of them are. This will be our final answer here, where it's positive. Square root of 2 plus root 3, all over 2. That's it. That's dope. That's fantastic, man. Not too bad. Not too bad, okay? A little scary, but overall, worked out pretty well. All right, now let's do sine of 22.5. Again, not a nice trig value, right? It's not a 30, a 45, or a 60 degree angle or reference somewhere else on the unit circle, but it is half of 45. So this could be rewritten as sine of 45 over 2, thus making my theta in this equation here 45. Cool. So I could rewrite this we could rewrite this as plus or minus. And you might be like already, hey, man, I know it's going to be positive because 22.5 is in the first quadrant. That's cool. You can get rid of the plus or minus right away. Depends on what order you want to do things, okay? So now I have 1 minus the cosine of 45. Well, what's the cosine of 45? It's root 2 over 2. Or 1 over root 2, depending on if you've rationalized it or not. But you may be so used to seeing root 2 over 2, we'll leave it as that. It actually works out pretty well in this to have it rationalized. I'm going to extend my radical. Oh, that's ugly looking. Okay. So we have 1 minus root 2 over 2, all over 2. And we can do the same kind of thing here. And you're going to see a lot of the same, procedures throughout, if you will, or all the algebra and like the simplifications are going to work out in the same way. If I multiply my numerator by 2 here, it's going to get rid of that denominator, make that a 2. But whatever I do to the numerator, got to do to that denominator so that I'm multiplying by 1. It's just a creative form of 1, and multiplying by 1 doesn't change anything. So let's clean this up. We've also already decided this thing is positive because 22.5 is in my first quadrant. Sine is positive in the first quadrant. So now I have the square root of 2 minus root 2 all over 4. Square root of 4 is 2. So we're going to get something like this. 2 minus the square root of 2 all over 2, not in the square root. It's a lot of 2's right there, man. But that is our final answer. And you can even plug in sine of 22.5 into your calculator. You'll get a decimal. Plug this in, you'll get the same decimal. It's a nice way to check yourself if you're, either working on like a homework problem or review or whatever, you don't have a key in front of you. You can actually type these in and check that you have the decimal equivalent. But most of the time on a test, these are going to be non-calc type tests to make sure that you aren't just doing that and finagling around with the common things. But you will see very similar answers coming up throughout with a lot of root 2's, root 3's, so on and so forth. All right? That's it for this one here, guys. I hope you guys enjoyed it. I enjoyed it. It's a lot of fun here, and have a wonderful, fantastic day.